We'll continue with 1 and 2 function. See a question given here. F is a function from, so that the function f from real number to real number defined by fx equals to 1 by x square plus 1 for all x belongs to 1 is neither 1 nor onto. Okay. Solution. You are for 1. What is the method you see? Suppose what is given? Your fx 1 by x square plus 1. So implies, or for fx1 equals to fx2, if you take fx1 equals to fx2, then you have to show x1 equals to x2. So what is fx1? X is replaced by x1. You will get here 1 by x square, x1 square plus 1, 1 by x2 square plus 1. Do a cross multiplication. So you will get here cross multiplication, x2 square plus 1, x1 square plus 1. 1 is cancelled. So what you get here is x1 square equals to x2 square. Yes or no? Then sorry, there is a mistake in this question. This is x, so this will be x1. Actually fx is x by x square plus 1. So this is x1 by x square plus 1. This is x2. So there will be cross multiplication. This will go here x1. This will go here x2. So what you do is, x1 x2 square plus x1, x2 x1 square plus x2. If you bring them one side, x1 x2 square plus x1 minus, or you bring here x2 x1 square plus x1 minus x2 equals to 0. Arrangement you have done. Then what you get? You are getting what is common here? x1 x2 common, x2 minus x1. If you want to make it x2 minus x1, then you can take a minus common here. That is x2 minus x1 equals to 0. So x2 minus x1 common, x1 x2 minus 1 equals to 0. This implies x2 minus x1 is 0, x1 minus x1 x2 minus 1 is 0. So what will you get there? Then implies x2 equals to x1. Okay, then you are getting x1 x2 equals to 1. Okay, we had taken x1 fx1 equals to fx2. You have to prove x2 is equal to x1. But the question is whether this is true or not. You have to verify. Either verify, this is already verified, that this part is verified or not, we have to check. So how to check here? If you take if x1 equals to half, x2 equals to 2, implies x1 x2 equals to half into 2, that is 1. But what do you get? x1 is not equal to x2. So this gives you, implies x1 is not equal to x2. So ये contradiction है. Because of this, actually what you have taken? You have taken your fx1 equals to fx2. What you should prove here? You should prove x1 equals to x2. But what are you proving here? x1 is not equal to x2 because of this statement. That means this is not coming equal. It should come equal. Therefore, f is not 1 1. F is not 1 1. Okay. For on 2, let you have taken from real number to real number, real number to real number. Okay, so 4 on 2, if I take so what is 4 on 2 then? So 4 on 2, what you will see is for all x belongs to R, any x belongs to R, you can see what is your fx, that is x by x square plus 1. Actually, for any element here, there should be an element here, that is on 2. For every element in the codomain, there should be an element in the domain. So if suppose because in the real number you find a number 1, in the real number you find a number 1 or not. If I say if your fx equals to 1, can I find a x here? That is what I want to check. That means I can write 1 equals to x by x square plus 1, implies x square plus 1 equals to x, implies x square minus x plus 1 equals to 0. This you remember gives no real values of x, gives no real values of x. Why? You can check it. What is the method to check? Why there is no real values here? The real value means that you can check x is equal to minus b plus minus b plus minus b square minus 4ac by 2a. This is the value or not? If you put 1 1 1, minus of minus 1 plus minus 1 square minus 4 into 1 1 by 2 into 1. If you factorize, so what do you get? So you are getting 1 plus minus negative root 3 by 2. So is no real values. Not a real value. Not a real value. That means, what is your conclusion? Because your set is defined from real number to real number. For every element here, we should have an element here. That means for 1, there exists no real value. Means for image 1, there is no pre-image. Therefore, f is not onto. Okay, this is one pattern. Second pattern of the question, you say, so that the function the function f from where? Real number minus 0 to real number minus 0. All the real numbers except 0 you are taking. So, defined by fx equals to 1 by x is 1 1 and on 2. Okay, is the domain, if the domain is replaced by n, that means this part is replaced by n. That means the new function will be from natural number to real number. Real number minus 0, will it be 1 1 or on 2? Are the results true? That is our question. Okay, see now. So how we have defined it? Now there is a set here. 1, 2, 3, minus 1, minus 2, minus 3 fractions. 1, 2, 3, minus 1, minus 2, minus 3 fractions. 0 is not included. Got the point? Is it 1 1 or on 2 or not? Look at your fx is 1 by x. Pick up anything. Suppose I take 2. If I 2x is 2, then f2 will carry where? 1 by 2. Then 2 will be related to 1 by 2. Suppose I take 1 by 3. If I take x is equal to 2, you are getting fx is equal to 1 by 2. If I take x is equal to minus 3, your fx is equal to minus 1 by 3. That means minus 3 related to minus 1 by 3, 1 by 3 related to 3. So for every distinct element, we have an element here. So how are you going to write? You are writing x1, or you can write fx1. This is the way to write fx2. So what is fx1? 1 by x1 equals to 1 by x2. Do a cross multiplication. you will get x2 equals to x1. Cross multiplication. So if fx1 equals to fx2, then if you get x2 is equal to x21, then f is 1. This is the way to show x1. You can write here x1 not equal to x2. You are getting fx1 not equal to fx2. This is the example you have shown. The general way of writing is this one. Okay, onto means what? For every element here, there should be an element here. So for onto, you have to take fx equals to y. Because you are taking y is an element here, for y there should be an element here. So y if you have taken, what is your fx? Now fx is 1 by x equals to y. Find x. What is x? 1 by y. X is 1 by y. Put any value of y except 0. If I put 1, 1 by 1 is 1. When y is 1, x is 1, that means 1 is related to 1 this side. Suppose I put y is equal to half. Then what will be your x? If I put y is 1, x is 1. If I put y is half you put here, x will be 2. So half will be related to 2. That means for all y belongs to codomain, there exists an element x in domain. So you can write for all y belongs to codomain, there exists an element x belongs to domain such that fx equals to y. Therefore f is onto. Means for every element under this definition you are getting element. Now the question is, now what is there? F is a function from natural number to real number minus g such that fx equals to 1 by x. So in that case what will happen here? In that case look at here, because ये तो possible natural number when you take 1 2 3 4 like this, 1 2 3 4 1 by 2 1 by 3, so many things you will find here because that is real number except 0. Okay, so if I write x1 is 1, x2 is 2, then your x1 is not equal to x2. What is your fx1? That is 1 by 1. What is your fx2? 1 by 2. So when these two are not equal, these two also not equal. Okay. Then you can write x1 not equal to x2, your fx1 is not equal to fx2. Okay, therefore f is 1 1. Onto look at here, there are some negative numbers. Minus 2 is there, minus 3 is there, minus 1 is there. So for all y there should be an element here. Achha, your fx equals to 1 by x. So y equals to 1 by x. So x is equal to 1 by y. Means for all y there should be an element here. Suppose I put y is equal to minus 2. Where? It is here. Then for minus 2 there should be an element here. Then what is your x? 1 by y. That means minus 1 by 2. But in the natural number minus half is not present. So you can conclude doesn't belong to natural number. Therefore, it is not available. Okay? Okay now. See another important question, very important question, try to see. That is, f is a function from एक important question. F is a function from real number, so natural number to natural number, defined by fx equals to x plus 1 if x is odd. अगर x odd हो गया, then you will take this definition, then my x minus 1 if x is even, so that x f is 1 1 and on 2. Okay, so that is the question. So first case 1, let for 1 1 let x1 x2 belongs to natural number and x1 x2 are even. Suppose, then what you will see here, both are even. So both are even means your x1 is not equal to x2. Different numbers have taken, so this is 2, this is 4. Both are even, so this is not equal to these two. Then your fx1 should not be equal to fx2. Now fx1 is what? Even number you have taken. Even means it will be x1 minus 1. fx2 x2 minus 1. Okay. Then if I take fx1 is not equal to fx2, I must show that x1 is not equal to x2. If I take, if your fx1 is not equal to fx2, then you must prove from here x1 is not equal to x2. So what is fx1? x1 minus 1. What is fx2? x2 minus 1. This gets cancelled. Implies x1 is not equal to x2. Therefore, f is 1 1. Which case? When both are even number. If I take both are odd, if case 2, if x1 x2 belongs to natural number and both are odd, both are odd number, so obviously your x1 will be not equal to x2. We can be 1 is 2, other one is 3. Sorry, 1 is 2, 3, other one is 5. So both are not equal. Now what is your fx1? Your fx1, when this is odd, your definition is x plus 1. So that will be x1 plus 1. What is fx2? Now x2 plus 1. Okay, then now for fx1 not equal to fx2, if you start like this, what you should prove? You should prove that x1 is not equal to x2. That means you will get x1 plus 1 not equal to x2 plus 1. So this gets cancelled. So implies x1 is not equal to x2. Means what did you get? If fx1 is not equal to fx2, you got x1 is not equal to x2. Why these two are different? Because both are odd you have taken. Odd means two different numbers you have taken here. Okay, second case gone. Third case is if one is even, other one is odd. Case 3. If x1, x2 belongs to natural number, x1 is even, x2 is odd. Obviously, even and odd are not same. That means first conclusion is x1 is not equal to x2. Let's check about fx1 and fx2. What is your fx1? fx1 will be, if x1 is even, fx1 will be x1 minus 1. Look at this, one is even, it is x minus 1, this is x1 minus 1. Then this implies, what is fx2? So what you will get fx2? This is our even number. The result will be even number, no? If x is even minus 1, even minus 1 will be odd. What I have taken? x1 is even, x2 is odd. x1 is even means even ka definition is x minus 1. The even number minus 1 will be odd. x2 is odd. When x2 is odd, what is the definition? X plus 1. So that will be x2 plus 1. Odd plus 1. Odd number plus 1 will be even number. So you get fx1 is not equal to fx2. You have taken x1 is not equal to x2. You got fx1 is not equal to fx2. Therefore, f is 1 1. Okay. For onto is which side? Actually, this is your x. This is your y value. The y value is in this form. Y value is x plus 1 form, x minus 1 form. Means once y will be equal to x plus 1 and once y will be x minus 1. Depends upon even and odd. Okay, so for onto, let y belongs to codomain. This is your codomain. Let y is any natural number belongs to codomain. Okay, then what you will get here? If y is even, if y is even number, y is even number, then what will be the value of y? Tell me, what will be the value of y here? This part will be even number when? This part will be an even number when y का value will be x plus 1. Check it why. So if y, this is an even number, this will be an even number, this result will be even number when, that means it is in the form of x plus 1, odd plus 1 will be even, that means y will be in the form of x plus 1, because when odd then plus 1, that becomes even here. Okay, so even number means, so what is the value of x here? Y minus 1. The x is equal to y minus 1. So y minus 1, this is where now belongs to domain. If this element is present here, this element carried by f, this element, if, where is the y now? Y is in the codomain. Okay, for the time being you forget this. This is confusing. The y is here. So y is here means y is x plus 1. So when y is x plus 1, then what is x place here? Now y minus 1. Then y minus 1 carried by f, this carried by f should reach to y. That means you have to prove f of y minus 1, f of y minus 1 should be y to show. From here you got y, x ka value y minus 1 means y minus 1 is present here. This should be carried to this place. So how it is possible? This has taken the x place now, because you are writing f of x is what? F of x is when the element is even, the element minus 1. So fx is what? X minus 1. So f of y minus 1, just imagine in place of x you imagine this. What will you get? Now f of y minus 1, what x is doing? Element minus 1. So this will be element minus 1. Okay, so element that is y. Okay, so what about if y is odd? Y is odd means y is odd. Y is odd means x plus 1 is odd. This will be odd. x plus 1 is odd. So what will be the value here? X plus 1 is odd. So when, what should be the x? Look at here. This is y, which is x plus 1 will be odd. This will be odd, means this has to be y is odd. So what will be the value of y? X minus 1 has to be odd. Why x minus 1 is odd? Because if y is odd, then x odd minus 1 will be, if y is odd, then y का value will be, y will be x minus 1, which is odd. Why? Try to understand. Y is x minus 1. Y is x minus 1. Achha, if x is even, then only, suppose so if x becomes x minus 1, then x is even. So when x is even minus 1 is odd. Even number minus 1, just like 4 minus 1, 5 minus 1. So when, 6 minus 1, when x is even, then the result will be odd. Odd means this is the format. That is a y will be x minus 1. So this implies x is equal to y plus 1. X is equal to y plus 1. If this is y, then here is y plus 1. So y plus 1, try to check it again. I am telling you which one is y. Actually this is your y, this is your y, this is odd. This will become odd when even number subtracted by 1 will be odd number. Even number subtracted by 1 will be odd number. So even, that means y will be in the form of x minus 1 form. Then only it will be odd. So x will be y plus 1. That means this is the place of x, this is the place of y. So for every y plus 1, there should be an y here. Now that means f of y plus 1, f of y plus 1 should be carried to what? Y now. So what will be f of y plus 1? That will be y minus 1 plus 1. Y, f of y plus 1, sorry, f of y plus 1 will be the element f of y plus 1 will be element minus 1. So this is answer, that is y. Okay, therefore f is on 2. Therefore f is on 2 implies f is 1 1 and on 2. This is one pattern. Another pattern you see, f is a function from real number to f is a function from real number plus to codomain is minus 9 to infinity. minus 9 to infinity, given by fx equals to x 5x square plus 6x minus 9. 5x square plus 6x minus 9. Then prove that f is 1 1 and 1 2. Prove that f is 1 1 and 1 2. Okay. Proof for 1 1. fx is given 5x square plus 6x minus 9. Now look at f of x1 is f of x2 implies x1 equals to x2. This is how we'll prove 1 1. You'll take fx1 equals to fx2, you'll prove x1 is equal to x2. So how to prove? Just start here. Replace x by x1. 5x1 square 6x1 minus 9 5x2 square plus 6x2 minus 9. This gets cancelled. Then what you'll do is take x 5x1 square 5x2 square plus 6x1 minus 6x2 equals to 0. If you take common, 5, if you factorize it, you will get x1 minus x2, x1 plus x2 plus 6 common, x1 minus x2 equals to 0. Implies x1 minus x2 common, 5x1 plus 5x2 plus 6 equals to 0. This implies either x1 minus x2 is 0 or 5x1 5x2 plus 6 equals to 0. This implies x1 plus x2 equals to x2. This is what you wanted to prove. But what about this part? But 5x1 plus 5x2 plus 6 cannot be 0. Why it cannot be 0? Because your domain is real plus. Since your x1, x2 belongs to R plus. R plus means sum of the real numbers cannot be 0. Okay, that means you have started with fx1 equals to fx2, you got x1 equals to x2. Therefore, f is 1 1. Let's check on 2 then. For on 2, what you have to see, look at what is the method? For on 2, y equals to 5x square plus 6x minus 9. Where is this y? Y belongs to, this I will explain you again here. Y is present here. This codomain. Codomain is minus 9 to infinity. So y is any element between this. So for an element y, there should be an element x here. That x will find out whether it is present in the real number plus or not. Because your domain is real number plus, codomain is minus 9 to infinity. You have taken any y here. For this y, you have to find an x, whether that x is present here or not. If it is present, then it is onto function. So let's find out x from here. How to find? What is the method? The method is make its quadratic equation 5x square 6x minus 9 minus y equals to 0. Let's find out what is a, 5, what is b, 6, what is c, minus 9 plus y. Okay, what is x now? Minus b plus minus b square minus 4ac by 2a. Okay. So minus 6 plus minus 6 square minus 4 into 5 into minus 9 minus 9 plus y. 2 into 5, that is minus 6 plus minus 36 plus 20, 29 the 180 plus 6y, sorry 20y. Okay, so what did you get here? What is common there? Common is minus 6 plus minus 196 plus 20y root over by 10. Okay, if you simplify it, what can be common? 4 will be common. Minus 6 plus minus 4 common means that will be 2. 4 is gone means 4 4 is 16. 3. If I take 2 common, minus 3 plus minus, that is 49 plus 5 y by 10. 2 cancel 5. Okay. Then you are getting minus 3 plus minus 49 plus 5y. Let's write like this, by 5 minus 3 minus 49 plus 5y by 5. This is rejected because your x, this is the value of x cannot be negative, so rejected. X belongs to r plus, so r plus means this is not there. Now you have to verify whether this one is present or not. Pick up any value from minus 9 to infinity. Suppose you put minus 9, how much you are getting? Because you will put what? Minus 9, minus 8, like this, it will continue or not? Any value pick up. Suppose the last beginning number, if I put minus 9, minus 45. So 49 minus 5, that is a root over of a number which will be present here. Okay. So you can find out whether calculation is correct or not. You have to check it from here. What was the calculation there? It should be 216, I think. That is, yeah, it was minus 36 plus 180 to us. So 180 means 216 actually. So 216 means this will be 54. Actually 54 it is. 54. So any value 9 minus 9 if you put also, the value which will come out is positive here. So you can write y belongs to minus 9 to infinity. Here x is minus 3 plus root over of 54 plus 5y by 5 belongs to r plus. Means what did I tell you? Any value between minus 9 to infinity, any value pick up here, there is an x here. So therefore f is on 2. Remaining I will study tomorrow.